Om Nam Shivaya. Good morning, children. Here you can see a candle flame, right? What is the color of a candle flame? Now you can see LPG flame and a candle flame, right? Here you can see flame of different Bunsen burners. Okay. Now you can see a candle flame, flame of a kerosene lamp and a flame of a Bunsen burner. Find out different types of materials and record your observations and mention whether on burning these materials forms a flame or not. Okay. The substances which vaporized during burning gave flames. For example, kerosene oil and molten wax rise through the wick and are vaporized during burning and form flames. Charcoal, on the other hand, does not vaporize and so does not produce a flame. Okay, now we have to discuss the structure of a flame. For discussing the structure of a flame, we have to do an activity 6.5 given in your textbook. For doing this activity, take a wax candle, fix it on a table and light it with a matchstick. Okay. Hold a thin glass tube with a pair of tongues and introduce one end of this glass tube in the innermost zone or dark zone or black zone of the candle flame. Now bring a lighted matchstick near the other end of the glass tube. Do you see a flame caught at this end of the glass tube after a while? Yes. What do we observe then? Or why do this happen? We observe that the innermost or dark zone of the candle of the heated wick consists of unburnt wax vapors. Some of this wax vapor enter the glass tube and come out from its other end. When we bring a lighted matchsticks near this end of the glass tube, the wax vapors coming out of it start burning, producing a flame. This activity shows that the innermost zone or dark zone or black zone of a candle flame consists of unburnt wax vapors. That is why we can see a flame caught at this end of a glass tube after a while and produces a flame. Okay, is it clear? Now, when the candle flame is steady, introduce a clean glass plate or slide into the luminous zone of the flame. Hold it there with a pair of tongues for about 10 seconds. Then remove it. What do you observe? Here you can see a circular blackish ring is formed on the glass plate or slide. It indicates the deposition of unburnt carbon particles present in the luminous zone of the flame. Now hold a thin long copper wire just inside the non-luminous zone of a flame for about 30 seconds. Notice that the portion of the copper wire just outside the flame gets red hot. This indicates that the non-luminous zone of the flame has a high temperature, or it is the hottest part of the flame. Now, combustion can be with flame or without flame. The substance which vaporize during burning give flame. The substance do not vaporize during combustion do not give flame. Okay. Now the structure of a flame. The first layer is outer zone of complete combustion, which is blue in color, and also it is the hottest part of the flame. The second one is middle zone of partial combustion, which is yellow in color. It is moderately hot. The third one is innermost zone of unburnt wax vapors, which is black in color. These are the three different zones of candle flame. Now you might have seen that goldsmiths blow the outermost zone of a flame with a metallic blowpipe for melting gold and silver. Why do they use the outermost zone of the flame? Yes, the outermost zone is of complete combustion and it is the hottest part of the flame. That is why they use outermost zone of a flame for melting gold and silver. Now, what is a fuel? The sources of heat energy for domestic and industrial purposes are mainly wood, charcoal, petrol, kerosene, etc. So, these substances are called fuels because they are combustible. What are the qualities of a good fuel? A good fuel is one which is readily available, it is cheap, it burns easily in air at a moderate rate. It also produces a large amount of heat. It does not leave behind any undesirable substances. So these are the qualities of a good fuel or which can be considered as an ideal fuel. But there is probably no fuel that could be considered as an ideal fuel. So we should look for a fuel which fulfills most of the requirements for a particular use. Fuels differ in their cost. Some fuels are cheaper than the others. They also different in their structure. It may be solid, liquid or gaseous form. Now fuel efficiency. Suppose you were asked to boil a given quantity of water using cow dung, coal and LPG as a fuel. Which fuel would you prefer? Obviously LPG we will prefer, isn't it? So that depends upon the fuel efficiency. So the amount of heat energy produced on complete combustion of 1 kilogram of a fuel is called its calorific value. It is expressed in a unit called kilojoule per kilogram. Now look at the table 6.4 given in your textbook. In this table, calorific values of different fuels are given. First one is cow dung cake. Its calorific value is 6000 to 8000 kilojoule per kilogram. That means when we burnt 1 kilogram of cow dung cake, it produces 6000 to 8000 kilojoule of heat energy. Now wood the calorific value is 17,000 to 22,000 kilojoule per kilogram. Likewise coal 25,000 to 33,000. So likewise petrol, kerosene, diesel, methane, CNG, LPG, biogas and hydrogen also have given in your textbook, isn't it? When we compare all these fuels, which one has more fuel efficiency? Which one has more fuel efficiency? Yes, hydrogen gas because its fuel efficiency is 1,50,000 kilojoule per kilogram. Okay. In second position, LPG is there because it has fuel efficiency about 55,000 kilojoule per kilogram. But for domestic purposes, we cannot use hydrogen because it is highly inflammable. So we are choosing the next option, that is LPG, CNG and methane, which is the major content of cooking gas. Okay, so that's all about fuel efficiency and calorific value. Okay.